Chapter 5, Quadratic Functions and Factoring. Five one, Graphing quadratic functions in standard form. Graph quadratic form is y equals ax squared plus bx plus c. Quadratic function, it can be written in a standard form. Y equals ax squared plus bx plus c, where a is not equal to 0. Because the graph of the quadratic function is a parabola, the graph y equals x squared is shown below. The lowest and highest point on the parabola is the vertex. The vertex y is equal to x squared equals 0, 0. Or the origin. Axis of symmetry divides parallel and the mirror images passes through the vertex, though the axis of symmetry y is equal to x squared is x equals 0. Function y equals ax squared plus bx plus c, where a is not equal to 0 and b is equal to 0. The vertex of the graph lines yx and ax is symmetric to yx. Graphing a parabola. You can use the steps below to graph in a quadratic function form y equals ax squared plus bx plus c, where a is not equal to 0. When a is greater than 0, the parabola opens up. When a is less than 0, the opens down. Step for graphing y equals ax squared plus bx plus c. Step 1, draw the axis of symmetry line. X is equal to negative b over 2a. Step 2, find the plot vertex. The x-coordinate of vertex is the x-coordinate of the vertex is negative b over 2a. Substitute the value x in the function and evaluate it to find the y-coordinate. Step 3, plot 2 points on one side of the axis of geometry. Use the geometry to plot more points on the opposite side. Step 4, draw the parabola through the points. Multiplying binomials. A monomial is a number, a variable, or a product of a number and one or more variables with a whole number solution and with whole number exponents. Binomial is a sum of two monomials. Your monomials are x, y to the third, 3, negative 5x, and 9xy. Binomials would be x minus 4, 2x plus x squared, x minus y, n minus 1. You multiply two binomials using FOIL method. The letters of the words remind you to multiply the first terms, outer terms, inner terms, and last terms, for example. Five two, graphing of quadratic functions in vertex-intercept form. A quadratic function can be written in a vertex form. Y is equal to a times x minus h squared plus k. Where a is greater than 0, parabola opens up. When a is less than 0, parabola opens down. Vertex of a quadratic function. Steps graphic a y equals a times x to h minus h squared plus k. Draw the x geometry. The line x is equal to h. Plot the vertex hk. Plot the 2 points one side of the axis of the symmetry. Use symmetry to plot two more points on the opposite side of the axis of the symmetry. Draw a parabola through the points. Graphing intercept form. If the graph of the quadratic formula has at least one x-intercept, the function can be written in intercept form. Y equals a times x minus p times x minus q. Where a is greater than 0, parabola opens up. When a is less than 0, the parabola opens down. The graph contains p0 and q0. Step for graphing a quadratic function or intercept form. Y is equal to a times x minus p times x minus q. Draw the axis of symmetry. The line x is equal to p plus q over 2. Find the plot vertex. Y coordinates of vertex is p plus q over 2. Substitute the x coordinates for the x function to find the y coordinate of the vertex. Step 3, plot points of the x-intercept and p and q occur. Step 4, draw the parabola through the points. Minimum and maximum values for standard form, vertex form, intercept form, quadratic function tells you the parabola opens up or down. A is greater than 0. The y-coordinate vertex is the minimum value of the function. A is less than 0. The coordinate that vertex is the maximum function. Five 3 x squared plus bx equal plus c. Alright, you now can write x plus 3 times x plus 5 is x squared plus 8x plus 5. The expression x plus 3 plus x5 are binomials. A trinomial is the sum of 3 monomials. X squared plus 8x plus 5 is a trinomial. You can use factoring to write a trinomial as a product of two binomial factors. To write x squared plus bx plus c as the product of x plus m plus x plus m times x plus n. Notice the pattern below. X plus m equals x plus m times x plus n equals x squared plus nx plus mx plus mn equal to x squared plus x squared plus m plus n times x plus mn. So factor 2x plus bx plus c, you can find the integers of m and n such as the m plus n is equal to b and mn is equal to c. Solving quadratic equation by factoring. Using factoring to solve a quadratic equation, one variable can be written in the form ax squared plus bx plus c is equal to 0, where a is not equal to 0. This is called standard form of the equation. If you can let a factor left side of the x squared plus bx plus c is equal to 0, then you can solve the equation using product property. Words: the product of the two expressions 0, then at least one expression must equal 0. Algebra let a and b expressions. If a times b equals 0, then a equals 0 or b equals 0. And then it gives an example. If x plus 5 is equal times x plus 2 is equal to 0, then x plus 5 is equal to 0, or x plus 2 is equal to 0. Five 4 factoring x squared plus bx plus c. To factor a trinomial in the form of ax squared plus bx plus c, write the trinomial as a product of the two binomials. You can factor ax squared plus bx plus c by finding numbers of k and j whose product is a, and numbers m and m whose product is c. So the k and j, ax squared plus bx plus c equals kx plus m plus jx plus n equal to kj squared plus kn jmx plus mn. So you take your non-coefficient products and you multiply them together and you would get c, and in addition you take your first factors here, binomial, k and j are equal to a. Factoring out a constant. When a factor of a trinomial x squared plus bx plus c, first check whether the term is a constant, common constant factor. Finding 0 of the function. 0 is a function x values of which the function values is 0. The 0 function are also x-intercepts of the function graph. You may be able to find 0 as y equals ax squared plus bx plus c, letting y equal 0, and factoring using the 0 product property. Minimum maximum values. As you learn in 5.2, you learn minimum maximum values of quadratic function and y value of the vertex. The vertex lies on the axis of symmetry. The axis of symmetry between x-intercept and zeros of function. The function has a minimum maximum value when x equals the average of the zeros. Your function intercept is y equals a times x minus p times x minus q for the maximum, or minimum values where x is equal to p plus q over 2. Factoring using special patterns. Some quadratic expressions can be factored by using special patterns. To see one special pattern, find the product x minus n plus x plus n using FOIL. You would get x minus n plus x plus n equals s squared plus nx minus nx minus n squared minus x squared minus n squared. So the result of the different two square patterns. Algebraic a squared minus b squared equals a plus b times a minus b. And the example would be x squared minus 4 would equal x plus 2, x plus minus x plus 2 times x minus 2. Alright, perfect square triangle. Let's do another special pattern. Find the product of x squared plus n squared. X plus n squared using FOIL. X plus n squared equals x plus n equals s squared plus nx plus n squared equaling s squared plus 2nx plus n squared, or x minus n squared equaling x minus n times x minus n equals x squared minus nx plus n squared equaling s squared minus 2nx plus nx. These results will leave the perfect square trinomials. You have algebra a squared plus 2ab plus b squared equals a plus b squared. And the example of that would be x squared plus 14x minus x squared plus 14x plus 49 equals x plus 7 squared. Algebra perfect square trinomial pattern a squared minus 2ab plus b squared equals a minus b squared. Example x squared minus 10x plus 25 equaling x minus 5 squared. Moving along. 5.6. Solving quadratic equations, finding square roots. A number b is the square root of a number if number a if b squared equals a. Positive number a has two square roots written in square root of a and negative square root of a. For example, because 2 squared equals 4, then negative 2 and negative 2 squared equals 4. The two square roots of 4 and 4 are square root of 4 equals 2, and the square root of negative square root of 4 equals negative 2. The expression as a radical sign over a. The symbol is a radical sign. The number beneath the radical sign is the radicand. Properties of square roots. You have the product property square root of a and b is equal to square root of a times square root of b. Example, square root of 8 is equal to square root of 4 times the square root of 2, which gives you an outside 2 of the radical, and then an radicand of 2. Quotient property, square root of a over b is equal to the square root of a over b. The square root of a over b is equal to the square root of a over the square root of b. For example, the square root of 15 over 16 equals the square root of 15 over the square root of 16, so you get the square root of 15 over 4. Simplifying square roots. You can use properties to above to simplify the expression containing square roots. Square roots expressions are simplified if no radicand has a perfect square factor other than 1, and there's no radical in a denominator. Or rationalizing the denominator. Simplifying the expression, you must eliminate radicand from the denominator. This is called rationalizing the denominator. It shows a simple solution of square root of 5 over 2 would be the square root of 5 over 2. The square root of 5 is and the square root of 2 times the square root of 2 times the square root of 2 is the radicate of 10 squared, the square root of 10 over 2. Simplified. Solving quadratic equations. You can use the square root to solve some quadratic equation. For example, a greater than 0, the quadratic equation is x squared equals a. Has two real number solutions. X is equal to the square root of a, or x is equal to the negative square root of a. These solutions can be written as x equals plus or minus the square root of a, which reads plus or minus the square root of a. Falling objects. When an object falls in its height in feet above ground after t seconds, can be solved with the function below, where h is the initial height in feet of the object. Model assumes the force of the air resistant to the object does not greatly influence the fall. So we have h, which is initial height, minus 16, negative 16 times the time in seconds squared, plus the height in feet, initial height. Alright, 5-7, complex numbers. Goal to understand and use complex numbers. The square of the real number x is never negative. So the equation x squared minus x equals negative 1 has no real number solution. Solve the equation. Mathematicians created an expanded system of numbers using imaginary unit, defined as a number that is I squared is equal to negative 1. Note that I squared equals the square root of negative 1. Imaginary unit I can be used to write the square root of any negative number. The square root of the negative number, so if r is the positive real number, then the square root of negative r is equal to the imaginary number, the imaginary square root of r. So the square root of negative 5 is equal to the imaginary number square, the imaginary square of 5. 2. By property 1, if the file says the square root, so the imaginary square root of r squared is equal to the square negative r. So imaginary times the square root of 5 squared is equal to the imaginary squared times 5 equal to negative 5. Complex numbers. As written in standard form on number a plus b, b imaginary, a plus a b imaginary, where a and b are real numbers. The number a is a real part of the complex number. The number bi is the imaginary part. The diagram below show the different type of complex numbers. You have real numbers that are complex that have no imaginary part, where b is equal to 0. And the imaginary always have imaginary numbers always have an imaginary part where b is not equal to 0, and pure imaginary numbers have no real part where a is equal to 0 and b is 0 and b is not equal to 0. A complex number to add complex numbers add their real parts and imaginary parts separately. So a plus b imaginary. Subtract complex numbers. To subtract complex numbers, subtract the real parts and imaginary parts separately. Multiplying complex number. To multiply two complex numbers, use the distributive FOIL with the FOIL method. Complex conjugates. The complex number of the two complex numbers on the form of a plus b imaginary and a minus b imaginary are called complex conjugates. The products of the conjugates always a real number that can use the complex conjugates to write a quote in two complex numbers in standard form. Completing the square. Alright, in lesson 5-6, you solve the equations for x squared plus equals to k, taking square roots. You can also use the method on each one side of the equation in perfect square trinomial. So we've now took a perfect square and we've put it into the trinomial and we've solved for x. Perfect square. Sometimes you can add a constant c to the expression x squared plus b to make the perfect square trinomial. This process is called completing the square. Each diagram below total area showed that x squared plus bx, the total complete square. The second diagram added a b over 2 squared. Completing the square. To complex the square of x squared plus bx, add b over 2 squared. Algebraic x squared plus bx equals b over 2 squared equals negative x plus b over 2 squared. Example, x squared plus 6x equals 3x, or x plus 3 squared. Solving equations. Many quadratic equations such as x squared plus 6x minus 5 or equals 0 can be solved by factoring. You can solve the quadratic equation by completing the square. Vertex form of the quadratic formula: y is equal to a times x minus h squared plus k, where h and k is the vertex. The complete squared written quadratic function vertex form. 5.9. The quadratic formula and the discriminant. Alright, lesson 5.8. You solve the quadratic experiment completing the square of each equation separately. By completing the square of one to the equation x squared plus bx plus c, you can develop a formula that gives the solution of the quadratic equation. The formula solution is called the quadratic formula. The quadratic formula lets a, b, and c be real numbers when a is not equal to 0. The solution of the quadratic equation of ax squared plus bx plus c are equal to 0 is the same as equal x plus negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Right in standard form. The quadratic formula can be used to find a quadratic equation that is in standard form. To use the quadratic formula to solve the quadratic equation, you must first write the equation in standard form. A squared plus bx plus c equal to 0. Using a discriminant, in the quadratic formula, the expression b squared minus 4ac is the discriminant of the equation a squared plus bx plus c equals 0. You can use the discriminant of the quadratic equation to determine the number of solutions, type of solutions of the equation. If b squared minus 4 minus 4 times a times c is greater than 0, there are two real solutions. If b squared minus 4 times a times c is equal to 0, there is one real solution. If b squared minus 4 times a times c is less than 0, there are two imaginary solutions. Vertical motion. In lesson 5.6, you've seen that the vertex, the h, is equal to negative 6, the height equation that we looked at. The height minus 16 times the second squared plus the initial height. So in the model of the falling after t seconds, the object launched or thrown, the term VO2, or vertical velocity, in time is used to account for initial vertical velocity in feet per second. Vertical motion models drop falling line. H equals negative 16 times t to the second plus h to the initial height in feet. Launched or thrown object, height of the object in feet minus 16 minus the time in motion second squared plus the initial vertical velocity of feet per second times the plus the initial height in feet. In vertical velocity, the vertical motion model of the launch object vertical value VO can be positive, negative, or 0, since the vertical velocity depends whether the object is launched upward, downward, parallel, or to the ground. 5.9 exercises. Chapter 5 extension, writing quadratic equation functions. Chapter 5, review, chapter summary and review. Quadratic formula, parabola, vertex, axis, symmetry, binomial, monomial, vertex form, intercept form, minimum value, maximum formula, trinomial, quadratic equation, zero, function, square, root, radical, radicand, rationalized, denominator, imaginary, complex, imaginary number, unit, complex conjugate, complex square, quadratic formula, discriminant. Chapter 6, Polynomials and Polynomial Functions. How has enrollment of students in public high school changed?